Welcome to a new video in my home automation series, and recently I made a couple of different videos on how I automated my irrigation and well how it is working at the moment. But there was an interesting history how this whole thing evolved in the last sort of like 12 years since I built a house, and of course the garden was done and the irrigation was done. And I think it's also like a story of how you can plan ahead, and then how your requirements and ideas change, how you can do automation as and when you start learning new things, and then sort of like new products come into the market that you didn't know about them initially. So maybe you can also draw some conclusions, and if you're planning to build something new, maybe I can also give you some ideas to think about. And I'm definitely not saying that this is the only way that it can be done, but this was my way, and there was a lot of like ups and downs and interesting sort of like sidetracks what I did. But I think I have something which I quite like the way it works now, and I've done quite a few videos of the sort of the latest brain of the automation that I did in Node-RED, and also how I integrated other sensors and different devices to work with this automation, which I'm also going to mention in this video. And I think probably like maybe in a couple of months or weeks time, once the irrigation season is going to be over here, I'm just going to wrap up everything that I have done, and just do maybe like one last video on how you can implement the same for yourself if you want to use my code, because I have done longer videos of how it works, going into the details and the coding, everything. Maybe it will be just nice to have a like a shorter summary video. Okay, so first of all, we are going to go back in time and talk about this irrigation. And oops, I just need to get used to this UI. So when I was building the garden and the house initially, I knew that I wanted to get the irrigation to work off the main PLC, which controls the lights and the heating and some of the other things in the house. But I wanted the irrigation system just to be like a regular thing that you use, valves, and that are commercially available. So I'm using Hunter in my system, I think, if I remember correctly. So there are 6 different zones, and I irrigate from a well or a water tank. I'm just going to come to the details of that a little bit later. So I have created a very simple thing in the PLC, a very simple program that I can specify at what time I want to start irrigation in the morning, and I created a time for each of the zones. So let's say the first zone turns on for 15 minutes or 5 minutes, and then the second zone, and the third, and the fourth, and the fifth, and the sixth, and it just completes. And of course, once whenever this starts, it turns on the well pump that you can see here. And well, it's not the well pump, it's the pump that pumps the water out of the tank, and then it just feeds to the sprinklers, and everything is quite straightforward from that point. And you can see some of the diagrams that I built for the touch screen. I mean, most of it is in Hungarian, but so this is the start time. So it starts at 6 o'clock, and this is the main switch. Either I enable or disable the irrigation. So what I did right in the beginning is I would just like in the evening said, oh, it was really hot today, the soil is dry, so I should start the irrigation. So I would turn this switch on, and then it will start irrigation at 6 a.m. And this is just a graph of the water level in the tank. So you can see that the pump is running, it just reduces. So the time resolution is quite small on this. And then it fills back up, and then next day, and then the same day as well. So that was one of the screens. And so you can see the 6 different zones. And these are the times. So the first zone runs for 9 minutes, 9, 9, 9, and 15. And the last zone, which is like the drip lines, that they run for half an hour. And you can also see, like, I took the picture from Google Maps, and I put the zones on it. And so this is how I created it. And my gardener said that I should not change the timing so much. I should rather just do a good irrigation, and maybe just not do it every day, but do it every second day or every third day, depending on the on the outside temperature, because it's much better for lawn and everything if there is like a good watering which soaks down into the soil instead of just lightly sprinkling the top. And then once these manual things started to become a little bit tedious, I created this other program where I would enable a program for the entire week. And I have the days of the week, so Monday, Tuesday, Friday, Saturday, and all the way to Sunday. And I would just toggle these on and off. So like, let's say this is a regular summer where I would water every second day. So, Tuesdays, Thursdays, and Sundays. And if it gets really hot, then I will start turning on these days. But that was still, like sort of manual, but it was still manageable because again, and let's say if it rained, there was a really big rain, I would just turn this off, and it would just not schedule, the irrigation for an entire week. Let's say if it was a really big day, rainy day, and you can see that the these are 5 of my 6 zones, or no, yeah, sorry, 5 of my 7 zones, and just regular valves, and it just feeds the various sprinklers. And I have this pump which pumps the water after the tank. And the only thing I have added is I have added these pressure valve here. So this is completely separate from the PLC and the irrigation logic. So that just shuts off the pump if the pressure is too high. So let's say all the valves are closed for one reason or the other. And it actually did happen in the past. So that was also a good learning, that my valves run off a circuit which I use the same circuit for the garden, and it is protected by a GFCI. And then something happened in one of the garden sockets or the garden lights or something, so the GFCI tripped, which means that the pump started running, but then none of the zones opened. So the pump was just pushing water against a closed system, and actually this elbow melted, and then it also, I think, burst open, and there was like water all over this place. So this is when I added this valve. So even I can turn this water on, I can turn this pump on even if everything is closed, and it would just shut off the pump after like, I don't know, 20 seconds or something like that. And if I open the tap, then it starts the pump again. So it is a really good fail-safe because so many things can fail. At least this was it was above ground, so it was inside, so I was able to see the issue next morning. And this is one of the panels that I built to control the valves. So basically, somewhere I have all the different lines coming in from the PLC, so all the digital outputs which turn on each of the zones. And then what you can see here is there is a 24-volt power supply here. And so if any of the valves are open, that opens this relay as well, which then turns on this 24-volt power supply. And then through these relays, it just feeds the 24-volt AC, which is required for these valves to open. So at least if none of the valves are open, this power supply doesn't get energized. Which is like 6 months of the year, so I don't have to come here. I have a separate breaker to turn this off if anything happens, but I thought I could save some energy as well if I just don't run this power supply throughout the whole year on standby. So it basically just only turns on if any of the valves needs to open. But yeah, it works nice, and yeah, I have these 6 relays for the zones that you have seen in the previous picture. Okay, then the water situation. So I obviously didn't want to water my garden from the city water, and also I was mandated to install. Well, I was either mandated to install a water tank in my property, or make sure that the rainwater is soaked into the ground within the property line. So I was not able to, like push it out to the street. So I decided that I'm going to install this water tank that you can see here. So this is like a 6 cubic meter concrete tank, which is buried in the ground. and all the gutters feed into this. So if I have some rain, then obviously this fills up and I can use the pump to irrigate the garden from these from the tank. But then if we have like dry periods, which does happen a lot in the summer, then I also had a well. And the issue with this well was that it wasn't giving enough water, so it doesn't have enough flow. So that's why it was a good idea to have this water tank anyway, or this cistern. So I use this irrigate from, and then the well basically just tops up this tank. So the well empties into the tank, and because the well has a very low flow rate, let's say if I water the garden for 1.5 hours, so all of these zones run for about 1.5 hours or 1 hour 20 minutes, it takes about double time for the well to actually fill up. And this well pump is also controlled by the PLC, and also the PLC has a sensor in the water tank, so it can measure the water tank in the level. So I just have a simple program to top it up. Whenever it drops below the level, then it turns the pump on, and then it fills up the water tank. And in order to make sure that the pump doesn't run dry, I have done some tests to make sure what level I can run the pump so it doesn't drain the well dry. So this is a 3-phase water pump, and I think it's a 3-phase. Yeah, I think it's a 3-phase water pump, and I have a VFD connected to it, and then that VFD is also controlled by the PLC, so I can actually control the frequency, and for that, and also I can control the flow rate. And I basically just figured out what is the rate that I can run the well pump continuously without running the well dry. And of course I could revisit this number because this was set whenever the valve was bored. So I'm guessing maybe the valve is not performing better, so I can increase the flow rate, but it works good enough. I usually water once a day, and by the next day the well pretty much fills the tank back up. So it works out just fine. And again, you can see some screens. So this is the screen for the well pump, which so here is the frequency. So I run the VFD on 29 Hertz, and I say that I want to maintain a level of 90 centimeters in the tank. So that's the tank level, and I just turn this on, that's the program which basically says, maintain it on this level. And I have another one which I can also turn on, and that's going to maintain or fill up the tank all the way through. But this 90 centimeters works out to be just okay, because that's still more water than what I need for a single irrigation, and it also leaves the tank half empty. So if it rains, then the rainwater has somewhere to go, and I don't need to use the well on that day. And also I've created these few fields so I can either see tell myself how long the pump was running. So like today it was running for 3.5 hours, and then the day before that so I can see the last 5 days of runtime. So this is just to keep an eye on things and then make sure that they did. So if I knew that I was irrigating, I would expect the well pump to run as well, unless there was some rain. Okay, and I also wanted to input some pictures. It's not going to be very interesting. So this is the top of the water tank, and this is the well pump, or this plastic tub where the well pump sits, and then you can see the bore down in the middle. I haven't opened this for like 8 years, and everything is fine. I never needed to service this one. That's so good. So this was how it was running for, I don't know, many years. And I also had this weather station, which I purchased when I was living in the UK. I bought it from Maplin. It must have been about 15 years now, and this wind meter has broken, and I was able to get a replacement, and I don't have the original mounting pipe for it, but it still works. So it measures temperature, humidity. It has a rain gauge, so it measures the millimeters of rain that has fallen, and also it has a rain gauge, so it measures wind speed and wind gust. Not that I use that for anything. And this is like a really old school 433 megahertz weather station. So there are some batteries here inside in this housing. and there is like an inside unit which shows all the data. And at some point I was able to find this RF Link Gateway project. I think it's a Dutch project, and they basically make a shield which goes onto the Arduino Mega, and that shield has a 433 receiver, and they have a sketch for Arduino which supports, I don't know, like hundreds of thousands of 433 megahertz devices, weather stations, like these wireless temperature, humidity sensors, switches, key fobs and everything. And I feed this information into Node-RED. So I'm using this RF link to get the data from this weather station, and I also have some battery operated doorbells which actually also feed into this, and that's how I get notification that somebody rings the bell at the gate. And this was also a very old project. I have a separate video on that, how I created these statistics. So this device supplies a simple millimeter reading, which is like an accumulated reading which resets whenever you change the battery, but then from that point it just ever increasing. So what I do is I keep reading this value and I calculate what the difference was every single hour, every single day, or every single week, so I can get some figures. And this is mostly for statistical reasons, so even if it rains in the evening or overnight, I can just look at this data and it's like, okay, was it like a really big rain, or was it just like a very quick storm with not much rainfall at all? So this is what I did in terms of integration many years ago, but then it wasn't yet used for the whole irrigation process. The two were completely separate. I was just looking at these charts every morning, and then based on that I made a decision if I need to delay the irrigation because there was a big rainfall. And just recently, which means that this last autumn or this spring, I built this ambient temperature weather station. So I had a weather station before, and I do have that Maplin weather station as well. But the problem is that obviously, in order for that to measure rainfall, it has to be out in the open, which means that the sun shines on it. And even though it has these louvres on the temperature gauge, it does go way up whenever the sun shines on it. So I wanted to have a separate one, which I built from pipe fittings and everything. Again, I do have a video on that, where I could place it on a northern side of a tree which is completely shaded. So this is what I'm going to use to measure the sort of like the real temperature in the shade. So not like how much it goes up when the sun shines on the meter. And that's based on an ESP8266 and ESP Home. So, and once I had all this information, I was ready for this new water calculation logic, which I found online. And that's basically a very simple logic, which all it says that you measure what's the maximum temperature was within a day. So you can see some of this data that I set up for myself. So if the temperature goes above 35 degrees or 95 Fahrenheit during the day, then my garden needs 8 millimeters of water. Just needs 8 millimeters of water. So obviously if the temperature is less, the garden needs less water. So that's sort of like in line with how much water evaporates from the ground, and also how much water the plants use depending on the temperature. And it just makes sense. If it's hotter, then obviously the plants needs more water. So I calculate this one, and for this I use the temperature gauge that I just showed you in the previous slide. And then at the end of the day, for me I think I run the calculation at 11 o'clock at night, but the only reason I do that at 11 because I get a notification and I'm usually up at 11, so I can just validate that. But I think it would make more sense to run this like in the morning, at dawn, or like 3 o'clock or 4 o'clock. So just before you make a decision whether you want to irrigate. And I mean, I usually irrigate like, as you see, 5 a.m. or 6 a.m. in the morning. So basically what you do is you create a water balance, which basically says that how much water the plants needs, which comes from this table, and then you add whatever rainfall, which comes from the rain gauge, and also whatever amount of water that you have put into the ground using irrigation. So that basically just a simple calculation of plus minus, that sort of stuff. And at the end you get a number. And if that number is less than 0, then you need to water your garden. And of course, when you water your garden, you add that amount of water into this calculation the next day. So let's say this, you start this calculation starts from 0, and then there is 30 degrees that day, so the plants need 6 millimeters of water. So the balance is 0 minus 6 is minus 6. Let's say there was no rainfall during the day, so that basically your balance becomes minus 6, and that's less than 0, so you need to run the irrigation. And of course, when you irrigate, you can also measure how much, how many millimeters or inches of, water you irrigate. So at the end of it, you add that to the whole calculation. So the way I think, I haven't really measured this, but what I noticed that if it gets, really, really hot during the day, 30 degrees, and if I 35 degrees, and if I run the irrigation every single day, then the garden is happy. So plants don't dry. So that sort of implies that whatever number of whatever millimeters of rain the grass needs, I was able to provide through irrigation. So whenever I run the irrigation, I calculate that I have irrigated 8 millimeters of water. So again, that 8 millimeters adds up. And then you can quite easily see that if you have above 35 degrees, then you have to irrigate every single day. And if you only have 30 degrees, then eventually that 8 millimeters that you add into the ground through irrigation only gets reduced by, let's say, 6 or 4. So at some point, the irrigation logic is going to skip one day based on this calculation. And that calculation is, again, like a rolling calculation throughout the day. So going back to my previous example, it was minus 8 millimeters. So I'm going to irrigate the garden. So that adds 8 millimeters, so the balance becomes 0. And let's say there was a big rain, which added 10 millimeters of rain, and it was only 25 degrees. So then the balance goes up 10 millimeters minus 4. That's still, the result is 6, so there is no irrigation needed. So then the next day is again only 25 millimeters. So the 6 balance on the next day is reduced by 4, so that still leaves you 2 millimeters. Let's assume there was no rainfall again, but again, it wasn't that hot, and there was a big rain 2 days ago, so the irrigation is still going to skip, and so on. So I've tested this. It seems to be working okay, and I think you can quite easily tune this logic by either changing this number, or if you think, or of course you can also change the number of millimeters that your irrigation puts into the system. So I think there is a lot of tuning in this logic, and I've taken these numbers from the article that I read, and it seems to be working fine, at least for my region. And there was a Hungarian article, and obviously I live in Hungary, so it's the same zone. So obviously you might need to adjust that based on where you live. And this is what I covered in multiple videos. So I have a Node-RED flow which does all this irrigation. So that basically just collects all this data, calculates the maximum temperature, also calculates the daily rainfall, and then runs the calculation to do this rolling balance. And then based on that balance value, it decides whether to trigger the irrigation. And for me, the way I trigger the irrigation, that I send a message, send a signal to the PLC to turn that switch on that you have seen in one of the earlier pictures, that, okay, so it makes a decision at 11 p.m. and then it turns the switch on, which then is going to trigger the irrigation 6 a.m. the next day. And I've also built this nice UI for that. That's what I featured in my recent video. So you can see all these data. So you can see how the temperature was going up and down, and that's this light blue graph, and that's that rolling balance. So again, that when it dips, that's when the calculation runs and lowers the water balance. based on the maximum temperature, and it goes back up because then it triggered the irrigation, and it was like, let's say, adding water to the soil, and then it goes down again and up, and of course, based on how much, if you had rainfall or weather changes, the shape of this changes, and in some cases it might just you know, if there was a big rainfall, then this would shoot up, and then it would just slowly, gradually lower based on how much water needed, and all the way until it reaches zero, it would just going to go down, and then, you know, it reaches zero or goes below zero, irrigation is triggered, then it shoots up again and then go down. So it seems to be working just fine. I'm not saying this is the, you know, the simplest logic, because you can have just soil probes and then use that information to have a threshold, and if the soil gets drier than that threshold, then just trigger the irrigation. But since I had all these sensors and weather stations, it was just easier for me to do this. And I get these notifications as well on Telegram. So this is the first one, that's the notification that I get at 11 o'clock. So let's say that irrigation is scheduled because it was a really hot day, there was no rain, and the water needed based on that table was 8 millimeters, and the balance became less than zero. So then the irrigation triggered. So that's like one of the dips here. And then the irrigation runs, and then when it finishes, then it adds that 6 or 8, I think it's 8 millimeters back to this calculation. And I just have another notification, that's 9 a.m. in the morning. It just tells me sort of like how much the water tank, how the level in the water tank changed. So you can see that minus 52. So from midnight it has gone down to 52 millimeters. So that's the amount of water that I pumped out for the irrigation. And I could see that the water tank pump was running for 81 minutes. So that's the total runtime of my irrigation routine. And it took 173 minutes for the well pump to fit it back up to that same level. Or it's not even same level because it's at 69. So I guess when this was running, then the well pump was still running. But that basically just tells me that everything is working fine because the water level got reduced. The cistern pump was running, which means that the irrigation did trigger correctly. And the well pump was also triggered because that it needed to fill the tank back up. So this is just me to see that everything was running, because if there, for any reason, let's say the valve don't open, then I don't see a dip in the water tank, and obviously the valve pump would not trigger. So I don't have this validation automated, but with this single message I can just quickly see that everything was fine in the throughout the night basically. And with this, I think I got the end of this presentation. Yeah, that was the last slide. So I hope it made sense, and also I hope it was useful at least to understand, you know, my thinking, and maybe you can also draw some conclusions and use maybe some of these at least, you know, whenever you design your irrigation system for your home. So I think that will be all for today. Thanks for watching, and hopefully see you next video.